your host, and we're going to get started even though we've got more people joining. Just as a reminder, you're muted and you please turn off your video as well. And if you happen to turn it on, I'll turn it off for you. Without further ado, I'm going to introduce the Eastman Charitable Foundation's Board of Trustees President, Sean Phelps. Sean, take it away.
Okay, thanks, Christina. Good evening, everybody, and welcome to the Eastman Charitable Foundation's annual Fall Forum. This is our first virtual Fall Forum because, you know, we've all had to learn how to do things a little differently. And as I was thinking about what a regular Fall Forum would be like, it's everybody coming into the hall where we're having the speaker and looking around and greeting their neighbors and shaking hands with friends. And we can't do that. We can't be in person. So I thought with about 120 registrants from all over, it might be helpful for you to imagine a room with people from a lot of different towns. So I'm just going to give you an idea of the places that are participating in tonight's presentation. So we want to welcome Grantham and Eastman, Enfield and Springfield. Welcome. Welcome to George's Mills and New London, Newbury, North Andover, Sutton, Concord, Hillsborough, and welcome to Hanover and Lebanon, all the way up into White River Junction, Vermont, and over to Sharon, Vermont. And particularly a welcome to those people who are joining us from Massachusetts, Rhode Island, and Texas. Thank you so much to all of you for being here tonight. I also know that there are probably many people who have joined us tonight who have never heard of us. You don't know what we do, who we are. So I'm going to take a moment to explain all of that, and it will only be a moment. So we have been serving the environmental interests of Enfield, Eastman, Grantham, and Springfield since 2005. Our mission is to promote environmental stewardship, education, and green recreation through grants and scholarships. Our grants are primarily driven towards supporting projects that will protect the watershed, protect our woodlands, and protect the wildlife habitat. For a lot more information on the details of what we give grants to, then you can visit our website at ecfnh.org, and you can see a detailed list of all the grants that we've given over the last 15 years. In 2013, we started a scholarship program for students in Grantham, Eastman, Enfield, and Springfield who are planning to major in environmental sciences or related fields. So typically we would give two, if we have qualified candidates, we'll give two $1,500 scholarships every year. And just as an aside, there's a really inspiring essay that's on our website now that was written by one of this year's scholarship recipients. I encourage everybody to go to ecfnh.org and read that essay so you can get an idea of the quality of students that we are supporting to go into the field of environmental sciences or a related field. Now, in the area of environmental education, it suddenly struck us that we have an interesting opportunity, even though we can't meet in person, with the technology that we've all learned to use. Not that we all love it, but we've all learned to use it. We can expand our reach for forums just like this. And we're so happy to do that. So if tonight works out, we may just continue this as offering a virtual forum along with an in-person forum when we are allowed to gather together again. So that will extend our reach beyond our local service area of Eastman, Enfield, Grantham, and Springfield. So we're very excited about that. You know, we all know that it's been a real challenging year for individuals and families, and certainly small businesses and nonprofits. So much has happened. I know in our case, like many nonprofits, we've had to just cancel our in-person fundraising. Many other nonprofits are in the same situation. We've been able to continue our focus on accomplishing our mission for this year, and we're proud of that. However, honestly, we're not really sure how next year is going to go. So if you are willing, if you would like to go to our website, ecfnh.org, click on our donate button and just donate anything that you feel you can. We would be so grateful. Or if you prefer to just throw a check in an envelope and send it to ECF, PO Box 1825, Grantham, New Hampshire, 03753. Equally grateful for your support. And talking about donations, did you know that when the CARES Act was passed in March by Congress, that act makes it possible for all taxpayers who just take the standard deduction to deduct up to $300 of charitable gifts through December 31st of this year, December 31st, 2020, to qualified nonprofits like the Eastman Charitable Foundation. So I'm just throwing that out there as food for thought. Also, I'd like to let everybody know that our board of 9 trustees, we're all volunteers. We have no paid staff. So the donations and the community support that we receive, that allows us, because we all volunteer, it allows us to put a lot more back into our local community and our environmental education program, our scholarship program, green recreation. And oddly enough, we just don't have an opening typically on our board, but we do. We have 1 vacant seat. So if you're a Grantham resident, a resident of Springfield, a resident of Enfield, you happen to have 3 to 4 hours a month that you'd like to volunteer for a really fun group, I would love to talk to you, and you can reach me by emailing trustee@ecfnh.org. I've talked way too long about the foundation. It's now time to introduce our fantastic speaker. Sherry Godlewski has worked for the New Hampshire Department of Environmental Services for over 20 years. She has experience with water, air, waste, and environmental health programs. She is currently the Resilience and Adaptation Specialist, Manager, sorry. She is also the co-chair of the Coastal Adaptation Work Group and a member of the Upper Valley Adaptation Work Group. She represented, she represented the New Hampshire Department of Environmental Services at the New Hampshire Coastal Risk and Hazard Commission. She also was involved as the Adaptation Work Group facilitator for the governor's Climate Change Policy Task Force and was instrumental in assisting New Hampshire to develop a climate action plan. Sherry has her Master of Science degree in Environmental Communications and Administration from Antioch University. Sherry is extremely well qualified to be presenting climate change in New Hampshire. So with that, Sherry, thank you so much for being here, and I'm throwing it over to you. Thank you.
Thank you, Sean. Thank you so much for inviting me tonight, and I'm happy to be here. So can everybody see my screen? Donna? Yeah, okay. All right, we'll proceed. So I'm going to talk about climate change in New Hampshire, but to talk about climate change in New Hampshire, I also have to mention a few things that are going on globally, as well as issues that are happening across the nation. So this slide shows you the evidence of 14 billion-dollar weather and climate disasters that impacted the United States during 2019. Each of these icons represents a $1 billion disaster that occurred of the country, and totaling $45 billion in disaster money that needed to be allocated to help communities and states recover from these events. And 2019 marks the 5th consecutive year in which 10 or more separate billion-dollar disaster events have impacted the United States. So they're inconvenient and they're very expensive. So if you've lived in New Hampshire a long time, you might be saying, well, I've seen a number of these events happen in the past. And it's true. If you look at the years between 1953 and 2002, that 50-year period, we have seen 15 disaster declarations and 3 emergency declarations. But if we look in the more recent past, of the years 2003 through 2018, in just 16 years, we have seen 21 disaster declarations of various types and 10 emergency declarations. And these are very challenging for our communities, and they're expensive. And this slide illustrates the federal reimbursement that we have received for emergency declarations and disaster declarations in our state since 1986. And I've normalized all these dollars so you can compare apples to apples. And you can see the 1998 ice storm that we all remember quite well. But what you can see from this slide is a pattern that's emerging right around 2005, where almost annually we're needing to ask our federal government to help us recover from some sort of weather-related disaster in the state. And now I want to orient you to a couple of images here that you're going to see similar ones in the next few slides. The upper image is the image of average temperatures, and you can see the various colors. Anything that's white is near average. Anything that's pink to red is warmer than average. Anything that's blue moving to a darker blue is colder or record coldest. And so what you can see from this upper image is that during January 2020, the United States was in generally warmer than average. The lower image on the right gives you total precipitation percentiles. And you can see that the color scheme is anything that's white is about near average or normal for what we would expect for precipitation. Anything to going darker blue is above average, and anything tan to brown is below average. And you can see that New Hampshire had below average precipitation in January. January, we had higher than average temperatures and lower than average snowfall. And everybody probably remembers this day. It was Sunday, January 12th, and we had such warm weather in New Hampshire. We had many records broken. It was 70 degrees here at my house. I was barefoot on my deck on January 12th. So we had a very warm January in New Hampshire. And actually, January was the planet's warmest January since record keeping began in 1880. And now this is a global image, and you'll see a few more of these. It's a similar color scheme to the one I just described, where your white areas are near average. Anything pinker to red is warmest, and blue the same way, coldest. So you can see that it's not just the land that's becoming warmer, but also our oceans are becoming warmer. And you can see the really warm spell in Europe right there. And then what happened in February is the Antarctic reached the highest temperature ever recorded there. On February 9th, it was 68 degrees Fahrenheit in Antarctica. And that measurement was taken at the Esperanza base there, as indicated in the upper left on this image. And during that time, the Pine Glacier saw a huge melt, and 120 square miles of ice broke off and went in. That's about 3 times the size of the city of San Francisco. So as we move through the rest of the year, we had similar situation, what I was showing you in January. Between January and March, we had above average temperatures and below average precipitation. And this is getting us set up for our drought that we're in right now. So that's why I'm explaining these couple of images. And again, in March through May, we had a similar situation. We had average temperatures and below average precipitation. Now, this is my cat Rudy, and he weighs 16.7 pounds. And he thinks our summers are way too hot. And he's absolutely right, because we are seeing an increasing number of days over degrees, but more significantly, our nighttime temperatures are increasing at a faster rate. From 1940 to 2017, minimum temperatures, or the coldest we get, have increased by 2.5 degrees Fahrenheit. And this reduced nighttime cooling can have serious health effects, especially in the summer. If people live in large cities like Manchester or even Concord, it's really warm all day and it doesn't cool down at night, their bodies don't have an opportunity to relax and allow themselves to cool. And that can lead to a number of heat-related issues. Concord had its fourth hottest summer on record with 25 days above 90 degrees, while Manchester had 32 days above 90 degrees. So this heat is coupled with smothering summertime humidity, and it's crushing past historical records. And all the indications are that this is not going to change. We're going to continue to move in a warmer than average direction. And these are high humidity days. And what we've seen is an increase of 112%, or a doubling of high humidity days compared to the days that we experienced between 1980 and 1999. So we're getting hotter and we're getting more humid. And then this is an image from summer, and the northern hemisphere had the hottest summer on record. And you see that in New Hampshire, we had some record warmth as well as much above average warmth. And when you look at this image, you see very little blue, interesting and consistent with all the other images that I've showed you. So we're in this very, very warm year right now. And again, it's not just happening on the land, it's also occurring in our oceans. You can see a lot of red in the oceans and not as much blue in the mid latitudes. And then Verkhoyansk, Russia, had 100.4 degrees on June 20th. It's the highest temperature ever recorded in the Arctic since record keeping began. And what's happening is the Arctic is 3 times as fast as the rest of the world. Now this area is 400 miles farther north than Anchorage, Alaska. And on this particular day, above the Arctic Circle was warmer than Dallas or Houston. And in fact, Siberia has experienced a very, very warm 6 months. The first 6 months of the year were very, very warm, and this is causing problems, as you can imagine. And one of those problems is the amount of Arctic sea ice is at a very low minimum. As measured on September 15th, it was the second lowest in a 42-year satellite record. The lowest Arctic sea ice extent was in 2012. That was a huge drop and a record low, and we're second to that at this point in time. And what happens is Arctic sea ice melts, it causes a feedback loop that's a little bit unfortunate because ice is white, and when sun hits ice, it is reflected back out into the atmosphere. But as that ice melts, it shows ocean, and ocean is dark. And the dark ocean absorbs that sun's heat, and it creates this loop where now the ocean's getting warmer, so it's melting more ice. As the ice drops off, it allows more heat to penetrate the ocean. So it's a challenging situation in the Arctic. As we lose ice, we get more and more warming, which causes more ice to be lost. Now I want to talk a little bit about what's happening right in the lower 48 and some of the Western wildfires and the impacts that we're seeing from those wildfires. You can see in the image in the upper left that the wildfires were occurring, and the dense smoke from those wildfires was being transferred all the way across the country. And it even impacted New Hampshire, where we had some vibrant sunsets. Although I have to say that these wildfires and their smoke did not impact our air quality. But if you look at the image on the right, you can see those various colors, and those are indicating air quality. And there's some hazardous, deep, deep purple hazardous conditions, as well as lighter purple, very unhealthy, moving all the way to unhealthy, and unhealthy for sensitive groups and moderate. So there's no registered good air quality in the region where these wildfires are happening. And the air quality impacts are very widespread. In New Hampshire, we have never seen air quality that is of the red, light purple, or dark purple nature. You would not be able to go outside and do any exercise or any vigorous activities. And as you get into the purple and the dark purple, you probably would want to wear a mask or just stay inside, because this air quality was very, very harmful to human health. The particle pollution that's associated with wildfire smoke is very, very unhealthy for our lungs and our cardiovascular system. Now let's go back to the image in the upper left, and you see, while those wildfires were raging and carrying smoke across the whole country, in the southeast, you see Hurricane Sally and Hurricane Paulette brewing right there all at once. When I saw this image, I was amazed to think of all these climate impacts happening to our country all at once. And even in New Hampshire, we saw some wildfires, again, not as extensive as the western ones, but there was a fire that was burning out of control on a river in the Merrimack, on an island in the Merrimack River in September. And then the White Mountains had fires too. And the fire chief said that he saw a fire that had burned down 2 feet into the ground because the soil moisture was absolutely gone. Very scary to think about these large types of fires impacting the White Mountains or anywhere else in our state. Luckily, the governor issued a proclamation that bans outdoor burning as well as smoking near woodlands statewide due to the extremely high wildfire danger. And luckily, we're seeing a little bit of rain here today that's going to help this. But what has happened with these periods of higher temperatures and lower precipitation, we've moved into a period of drought. And you can see from this image that our entire state is in either a moderate drought, as is indicated by the tan color in the southwest portion of the state, and then the orange is severe drought, and the red is extreme drought. And I live in the area where we're in extreme drought. All those dots that you see on this map are water restrictions, either mandatory or voluntary. And for those of us who live with a private well, we pay close attention to this situation when we're in drought. Our town doesn't have a voluntary or mandatory restriction, but we are all on private wells. And so we have to watch what we're doing in terms of how we're using water in our daily lives. And even if you're not on a private well, even if you're in a community system, you should still be conserving water because you're all sipping from the same groundwater, and our groundwater levels are very, very low, even if you have a surface water drinking water system. So it's important for all of us to pay attention to this current drought and to conserve water. We shouldn't be watering our lawns. We shouldn't be watering outdoor plants. Just let everything go into hibernation. It'll come back. It'll come back in the spring. So we are in another drought in New Hampshire. And this is the drought monitor of the whole country. And I wanted to show you this as comparison to what we're experiencing in our area, New Hampshire, Maine, Vermont, and New England. You can see the same image, which is smaller here because I blew it up for the other picture. But what I want you to see is in the western states where all the wildfires are, they are experiencing extreme drought and exceptional drought. There's even darker red colors there. And they're short and long-term droughts. Now, usually the droughts that we experience are short, but they last, pretty much less than 6 months or so. But we are showing L here in Maine too, short and long-term. Long-term also indicates drought that lasts for longer than 6 months. And out west, some of these areas are definitely seeing long-term droughts, but we're also seeing some short-term droughts. And it's interesting because the only part of the country that's not experiencing drought is the southeast. And that's where they've been hit by numerous hurricanes. And speaking of hurricanes, it's been a very, very active season. We've had 25 named storms in 2020, and 10 of those have made US landfall. And poor Louisiana, they got hit a couple of times, and Hurricane Delta was the second hurricane to slam into them in 6 weeks. I don't understand how these people can recover from this. It's very, very devastating. And the Atlantic hurricane season is not over yet. And these hurricanes are brewing bigger and stronger because of the warm ocean and sea surface temperatures that are all a part of a warming planet. So there's a new science that is the science of attribution, and scientists are now able to link extreme weather events to increases in carbon dioxide in the air from the burning of fossil fuels. The more atmospheric carbon has boosted the odds of these extreme weather events: cold, drought, punishing storms, etc. And in 2016, the National Academy of Sciences released this statement. And what they said was, as the climate has warmed over the years, a new pattern of more frequent and more intense weather events is unfolding across the United States and the globe. And because of a rapidly advancing new area of science called event attribution, we can now estimate how climate change increases the risk to society of some types of extreme events. And interestingly, Hurricane Florence was the first forecasted storm to use an attribution statement. When they were predicting the storm, they said that the storm will be larger at landfall because of human interference in the climate system. And so that was the first attribution statement made in advance of a storm. And when they did the retrospective analysis after the storm, that statement held up. And so you can imagine that there's a lot of interest in the science of event attribution. So let's just talk a little bit about the difference between weather and climate. Weather is a set of conditions at any given point. It's raining today, tomorrow it might be a little bit sunny in the afternoon. And so that's how we talk about weather. We talk about weather all the time. But when we're talking about climate, we look at the average set of conditions over a period of decades. And usually when we're talking about climatic conditions, we're looking at 30-year averages. And so you can make the analogy to this as your mood, okay? So the weather is your mood. It's how you're feeling today. But climate is more like your personality. Like, what are you like pretty much all, for the most part of your life. So weather is a short-term, day-to-day, whereas climate is longer-term based on conditions over a period of decades. So this is how it all starts to happen with our warming. The sun brings radiation to the planet, and some of that sun is absorbed and it heats the planet. And then some is reflected back out into the atmosphere. And around the planet, we have this really nice blanket. The atmosphere serves as a blanket. And the atmosphere is made up of all sorts of gases, and it allows us to live here. So we like our atmosphere. But what we're doing when we're using fossil fuels is we're putting greenhouse gases into our atmosphere. And these greenhouse gases trap the heat. And so if we have more greenhouse gases, we have more ability to trap heat on the planet. And it's just like you, if you were in bed and you added a big fluffy quilt, you would start to get warmer and you might get a little, and that's what our planet is doing. And over the past 50 years, the average global temperature has increased at the fastest rate in recorded history. And the burning of fossil fuels for transportation is the largest source of these heat trapping pollutants. The second is electricity generation, and that just flipped in 2016. Prior to 2016, the number one source was electricity generation, but we've changed some of our generation. We're moving away more and more from coal-fired power plants. We're switching over to natural gas, which has less greenhouse gases. It's still not great, but it has less greenhouse gases. We're also doing more with efficiency with electricity use, as well as bringing renewables online. So we've done a lot for electricity generation, but our transportation is now the largest source of these heat trapping pollutants because of the burning of fossil fuels. And we Americans love our cars, right? So we need to be thinking both about electricity generation, but also really thinking about how and why we drive. So this global warming causes the climate to change. The greenhouse gases trap heat. It warms our atmosphere, causing overall warmer temperatures, but it changes the water cycle. Some areas see more rain, some see less. Oceans warm, glaciers melt, and sea levels rise. And this carbon dioxide and other greenhouse gases in the atmosphere also affect plant growth. And it all started during the Industrial Revolution. We became mechanized. We were doing great things. We were producing all sorts of stuff, and we were burning fossil fuels to be that mechanized and moving forward. And so from the start of the Industrial Revolution, we have raised the carbon dioxide levels from about 280 parts per million to now 411 parts per million. So that's a significant change to the carbon dioxide levels in our atmosphere. And how do we know this? Because we have different ways of measuring carbon dioxide. Scientists go into high mountain regions in Alaska and Greenland, and they collect ice cores. And this is an image of Dr. Cameron Wake and his team in Nepal. And you can see in their hands, they have a ice core. They're drilling down into the snow and ice to get to as far deep as they can. And then they pull up that ice core. And this is what one of the ice cores look like. And then they analyze that ice core. They can do thin sections of the ice core and look at it under a microscope. And those blobs would represent carbon dioxide in the atmosphere when that layer of ice was laid down. They also have other techniques where they melt the ice and capture the elements and compounds that were in the atmosphere when the ice was laid down. We can learn a lot about our history by looking at ice cores and drilling down into layers and layers of ice that represent how things were laid down in the past. But we also are doing ambient monitoring or background monitoring on Mauna Loa in Hawaii. And we've been collecting background data on carbon dioxide concentration and other greenhouse gases at the Mauna Loa Observatory since 1956. So we have really good data and abilities to measure carbon dioxide in our atmosphere. So now we're going to look at those carbon dioxide concentrations, and I'll explain this graph. In the right part of the graph, you see the arrow which represents the Industrial Revolution. Along the bottom line of the graph, you can see we're looking kind of like down one of those ice cores from the Industrial Revolution back to 400,000 years. And the up and down axis on this graph represents the concentration of carbon dioxide in our atmosphere. And you can see there are natural fluctuations to carbon dioxide. Sometimes carbon dioxide is low, sometimes it's high, but it never has gone over 300 parts per million in the past 400,000 years and even before that. And when we got to the Industrial Revolution, as I mentioned in the previous slide, we were about 280. Moving forward from the Industrial Revolution, here we are today. We're at 411 parts per million. This is an amount of carbon dioxide in the atmosphere that we have not seen in over 400,000 and even more than that years back. So while that's interesting and alarming, what's even more interesting is when you overlay temperature on the carbon dioxide graph. What you see is a strong mirroring between temperature and carbon dioxide. When the carbon dioxide is low, the temperature is low. When the carbon dioxide is high, the temperature is high. And so from this graph and moving forward, you can see that if we are up to 411 parts per million in our atmosphere, we're going to expect that the temperature is going to mirror that concentration. And so we're likely to see warmer temperatures globally. And in fact, the 10 hottest years globally have all occurred since 2000, and the last 5 are the hottest 5. And I think what I've been reading is that 2020 is going to fit in somewhere here between 2019 and 16, depending how the rest of the year goes. And then this is an interesting graph. This shows us the record highs and the record colds, the records hot and the record colds. And what you can see, if you just look at the graph color-wise, that the blues are decreasing, the record colds are decreasing, and the oranges or the reds are increasing. And so far in 2020, all of our records have been record highs in Concord, New Hampshire. We have not seen any record lows in Concord, New Hampshire this year. So when the planet warms, it doesn't do so uniformly. The planet is warming, as I mentioned earlier, faster at the Arctic, and the temperature difference between the Arctic and the mid latitudes is what keeps this jet stream moving in a very tight and predictable fashion. And the jet stream keeps the cold air in the upper Arctic areas and the warm air here where we live in the mid latitudes. But as the Arctic warms, the temperature differential between the Arctic and the mid latitudes isn't as great. So it's not keeping that jet stream in a consistent, predictable pattern. So the jet stream begins to wobble and it becomes a little less predictable, and it can dip down cold Arctic air into our region, and it can lock it in there for days. And we first started talking about this back in 2015 when we were talking about the polar vortex, and we were really cold here in New Hampshire, and we had a lot of snow. We had feet of snow that year. And at the same time that year, Alaska was so warm, they had to move the Iditarod dog race farther north, and they had to import snow for the start. So the changing Arctic temperatures are causing the jet stream to be more unpredictable and get stuck in patterns like you see here for a long period of time. And so we are making changes to our atmospheric currents by warming the planet. And here's an image of the polar vortex that we experienced in January 2019. You can see that Arctic blast has come down into our region, making us very, very cold for those 9 days. And it was very, very cold, while the rest of the planet was much warmer. So this winter, when there's a cold day and people say, see, there's no global warming, you can let them know that, well, no, actually these polar vortex events are also an indication of a wobbly jet stream that is being brought about by a warming planet. So this changing jet stream exhibits crazy behavior, and it does it in the summer as well. And because in the summer, warm air holds more moisture, and when this air is stirred by a hurricane, that moisture can manifest as intense rainfall. And we've seen that in some of the hurricanes that happened in Hurricane Sandy. Hurricane Harvey had over 60 inches dumped in Houston. And so, Houston. So this wobbly jet stream happens in the summer and in the winter. It's the same phenomena as the polar vortex. And this wobbly jet stream is predicted to increase by 50% if emissions of carbon dioxide and other greenhouse gases continue to go unchecked. So we're altering our atmospheric currents. And now let's talk about the ocean and the Gulf Stream. First, let's look at this image. If you look at the observed temperature change bar at the bottom of this image, you see that anything that is sort of orange to red is warmer than average. Anything blue to darker blue is colder than average. So at first glance of this, you can see that the ocean is getting warmer in general. Now let's look at this ribbon moving through here. This is a ribbon, but let's think of it as a conveyor belt. So as we start to look at the conveyor belt, we see that it's warm sea waters are moving up into higher latitudes, where usually they are made colder because it's colder in the higher latitudes, and that cold salty water is more dense than warm salty water. So cold salty water when we get the cold salty water, it's more dense and it drops down deeper into the ocean and continues that conveyor belt by a lower ocean current, a deep ocean current that's colder, goes back down into southern latitudes, warms up, and moves back up into our region to create this ocean circulation. But because the Arctic is melting and Greenland is melting, they're both putting, oops, sorry about that. Oh, geez, sorry. Wait a minute. I'm going the wrong way. Sorry about that. There we go. They're both putting, cold, fresh water into the system. So when these these warm surface currents come into this region, they're getting colder, but they're not as salty. So they're not as dense. So they're not sinking down to form that deep ocean current to keep this conveyor belt going. And so that's a problem. This circulation has declined in strength significantly since the mid-20th century, and it's a new record low. So we're very concerned about it. And you may have experienced this if you went swimming in the ocean this summer, because the area off our coast known as the Gulf of Maine is warming 7 times faster than the rest of the ocean because of these warm surface currents bringing the warm water up into our region, and it's stalling. And so this area in the Gulf of Maine is becoming warmer. So we're altering our atmospheric currents, and we're also altering our oceanic currents. Luckily, we have some local data that's provided to us through these regional and local climate assessments. And these are put together by Dr. Cameron Wake and his associates at Climate Solutions New England, affiliated with the University of New Hampshire. And I'll talk mostly about the Southern New Hampshire assessment because that pertains to our region here in East and where you all live. So luckily for us, we have local data and we can learn where we've been in the past, where we are now, and what we can expect for future conditions. In general, what we've already seen in New Hampshire is an increase in precipitation in both rain and snow. And these events are happening in larger amounts and more intense storms. So we're seeing an increase in intensity of storms as well as the amount. We're getting dumped with a lot of rain and a lot of snow when we have these big events. We're seeing an increase in overall average temperatures, increases in extreme weather events, changing seasonality where our winters are shorter and we see spring melt happening a bit earlier and fall frost maybe happens a little bit later. We're seeing periods of drought, and we're also seeing sea level rise in New Hampshire. Portsmouth's sea level has risen 6 inches since 1926. We're seeing weekly high tide flooding in Hampton, not from storms, just as the tides come up, it's flooding the streets of Hampton. And as sea level comes up, so does groundwater. So we're seeing increases in groundwater levels, and I'll explain those a little bit more as we move forward. So what we've seen in the Northeast already is a 71% increase in extreme precipitation, while other parts of the country in the West and the Southwest are not seeing that increase at all, which is leading to drought and supporting the wildfires. This is an image of the drought in 2016. Again, you were acquainted to this sort of image before when we were talking about this year's drought, but we're having these periods of short-term drought. We had one in 2016, and here we are again in 2020. And we're seeing sea level rise. So these are images from coastal New Hampshire at a king tide. A king tide is some of our highest tides of the year. They occur a couple of times, and they are a combination of orientation with the moon and the sun and the earth causing a gravitational pull, causing a little bit higher than normal tide. And so these are king tide images. And you can see the streets of Hampton are flooded. It's a beautiful day. There's no storm. It's blue skies, and people cannot park on their street. Another thing that we're seeing in New Hampshire is an increase in vector-borne diseases. And black-legged ticks, which we're very familiar with, some people have called them deer ticks, can cause Lyme disease as well as other diseases like anaplasmosis, babiosis, and Powassan virus. And we're seeing more of these infections in people in New Hampshire, and as well as in dogs. So check your animals. And the increase in ticks is caused by shorter and warmer winters, but it's also caused by an increase in development and fragmented landscapes. When we develop and we fragment natural forests, those edges are where the ticks can live on their hosts. So white-footed mouse and deer are the hosts for these black-legged ticks. And so you pay attention to your yard and the edges, and be sure you're careful when you go in those areas, because you want to make sure that you're checking for ticks as well as for you, your children, your dogs. We're also seeing increases in mosquito-borne illnesses, and they have a number of diseases as well. And these mosquito-borne illnesses are caused by warmer summers, increases in humidity, and precipitation. If we have standing water, it's perfect mosquito breeding. So pay attention to what's on your property, especially after this rain, and make sure there aren't standing puddles as we move into warmer days. And there's a new surge of black-legged ticks right now. I picked ticks off my cats and my dogs today before I started this presentation. So keep an eye on everybody in your home. If you're an allergy sufferer, you already know this. We've seen an increase from 13 to 27 days of pollen season in the Northeast. And ragweed is one of the irritants that affects many, many people. And the bad news is that ragweed loves carbon dioxide. And so in 2011, this research was published, and in 2011, the average ragweed plant produced about 11.3 grams of pollen. By 2070, that could double. So it's a longer season and there's more pollen per plant. So I'm sorry for you allergy sufferers, because I know you know this better than me. The other thing you may have noticed is poison ivy loves carbon dioxide. It grows bigger and it's more toxic, and it's all around my property, and you have to be very, very careful, especially if you have animals who run through it and then come and want to be snugged up. So poison ivy and other pollen creating plants love carbon dioxide, so pay attention. There's also ecological impacts from all of these changes, and you've probably read about the moose and the impact the winter ticks are having on the moose population. And because of the warming winters, these ticks are hanging on to moose and really causing problems for them and making it harder for them to reproduce successfully, because they're challenged all the time because of the ticks on them year round. You also see problems with birds when they come back to New England after they've been away. They may be coming back earlier because the spring has come earlier, but their food sources aren't here. And so there's problems with food source timing for migratory species, as well as these erratic weather patterns. And then there's pests and invasives. If you're a gardener or if you work in forestry, you're familiar with the increase in pests and invasives that we're seeing around us. This is an image of the emerald ash borer, which is decimating the ash trees in our state and causing many of them to be cut down just so that they can at least harvest some of the wood before it's rendered useless. Ocean species are changing very significantly. Our cod have moved north due to the warming, and their food source has moved north, so they went north as well. The southern New England lobster population has moved north. The southern New England population for lobsters is not as strong as it used to be. We're still okay here, but we're paying attention to that. The shrimp population collapsed in the Gulf of Maine in 2013, and it hasn't rebounded yet. And our clams and oysters are becoming more contaminated due to the increased rain events and pollutant runoff, decreasing water quality, impacting the shellfish, and then their shells are impacted by ocean acidification. So these are things that we're seeing right now and something we definitely need to keep an eye on. And then because of the way New Hampshire lives, we have a lot of natural system economies, right? And these natural system economies are seeing huge impacts. The maple industry is tapping in January now just to catch those first runs, and sometimes going way into March and April to try to capture as much as they can, because it's limited because the weather is so erratic. The ski industry has had to try to adapt. Any snowmobiling is challenging if you don't have good snow cover in the winter. And this all impacts our tourism because we're a very tourist-based economy. And of course, anyone who gardens or works in larger scale agriculture knows that it's a challenge, especially in a summer like this summer, where they had to choose which crops they were going to water so that they could at least have some return from their investment. So I just want to say that climate change is real. 99% of all climate scientists agree that climate is changing and it's likely due to human activity. And the impacts of climate change are already being felt by our communities across the country and across the globe. These extreme events disrupt and damage critical infrastructure. They affect our economies, our natural resources, and the vitality of our communities. So, what are we going to do? We have a choice. We have many choices. We can do nothing and continue with business as usual and just hope for the best. Or we can start to mitigate or reduce our use of fossil fuels so that we put less carbon dioxide and other greenhouse gases into the atmosphere. And we have to begin to adapt. We have to prepare for the current and future impacts that we are going to experience. Now, many people have asked me, so with the pandemic, did we see a big decrease in carbon dioxide, and has that helped, push back climate change? So I want to address that for a minute before I continue with other choices. So during the pandemic, we did see an increase in air quality, especially in large cities. LA, some cities in China reported seeing much better air quality. But in terms of carbon dioxide, and that air quality improvement was short term as well. Once we started moving around again, the air quality, and in New Hampshire, our air quality went back up to over 2019 levels of pollution, because we weren't all driving, but many people were ordering from Amazon and other companies to have home delivery. And so there are a lot of trucks still on the road doing deliveries. Remember the shortage of toilet paper, and everybody was freaked out. So everybody was ordering. So there was still movement, and it still caused pollution. And in terms of carbon dioxide, I want to talk about the difference between carbon dioxide concentrations and carbon dioxide emissions. So in May 2020, the carbon dioxide concentration, which I told you now today is 411 parts per million. In May, that carbon dioxide concentration went up to an all-time high of 418.12 parts per million. Now, there are some natural variations in carbon dioxide concentration in the atmosphere, and often we look in May to see what the concentrations are, because once all the plants start to bloom in and around May, plants take in carbon dioxide. So they can bring that level down a little bit. Like here, it was 418 in May, and here in September, it's 411. So it's still high, but we do see a minor reduction seasonally. But in May, we hit an all-time high. So we had been locked down for half of March and all of April, but we were still seeing concentrations of carbon dioxide in the atmosphere at an extreme high. So small reductions in carbon dioxide emissions during the pandemic did happen, right? Because we weren't all driving around. So that's the emissions, what we're putting into the air today. So concentrations, the carbon dioxide concentration in the atmosphere, which we just talked about as being 411 parts per million, is a result of many years of emissions. So as we continue to emit carbon dioxide and other greenhouse gases into the atmosphere, they hang around. And carbon dioxide can hang around in the atmosphere for hundreds or even millions of years. So essentially, we're breathing the carbon dioxide our grandparents emitted on their honeymoon, because it hangs around in the atmosphere. So when we reduce emissions, even slightly or short term, like we did during the pandemic, this does not immediately reduce the overall concentration in the atmosphere. The atmosphere is a huge place. It's got a lot of gases in it. And so small reductions aren't going to reduce the overall concentration. It's like if you're filling your bathtub and you have the water on full blast and it's filling up, and you turn the water back a teeny bit, it may not be filling as fast, but it's still full. You've reduced the emissions at the faucet, but the concentration of carbon dioxide in the atmosphere is the amount of water in your bathtub. So emissions, what we're putting out into the atmosphere today, need to reach virtually zero by 2050 if we're going to avoid the worst climate change scenarios. So we have to do a lot to reduce our emissions so that can help the overall concentration in the atmosphere. I hope that's clear. If not, you can ask questions. So let's get back to what we can do. Well, we have to continue to reduce our fossil fuel use. And you probably don't own your own fleet of vehicles, but our agency does. And so we purchase fuel efficient fleet vehicles, and you can all purchase fuel efficient personal vehicles. This is a hybrid vehicle. We also have hybrid electric vehicles now, and there's many great electrical vehicles or hybrid electrical vehicles on the market today. And these cars are priced comparatively to regular gasoline vehicles. So if you're looking for a new vehicle, really think about the efficiency of that vehicle. You can purchase something that's better for the planet. Looking at your home or a business, you should start with a home energy audit. They're awesome. If you've not had one, they're a great thing to do. It helps you to isolate which areas of your house need the most attention. And in New England, what we find, especially in New Hampshire, many of our homes really need to be insulated. And if you insulate our homes and our schools and our businesses, not only do we stay warmer in the winter, but we stay cooler in the summer. And ultimately, we use less fuel to power heating or cooling in our homes, schools, and businesses. Renewable energy is very, very much more affordable these days. This is my garage, and we first put in the 10 panels that you can see on the main part of the garage. But then just last year, we put the addition on the garage and added the additional panels. We feel good about this because this covers all the electricity use in our home, and we're able to convert some of our appliances that were propane to electric, like we have an electric hot water heater now. So and I work for the state and I could afford this. So they are more affordable, and it's the right thing to do for the future of our planet. And we have to think about using energy efficiently. This is an image of a faucet in our bathrooms at the agency. And you can see the little solar cell on top of the faucet. That uses the ambient room and the light to bring water up through and wash your hands. So it's a great little system. We're probably not going to install these in our homes, but in the Department of Environmental Services, we have these in all our restrooms. And it's a great way to use water and energy efficiently. And let's talk a little bit about food, because we waste a lot of food in this country. And if you throw food into a landfill, it biodegrades into methane. And methane is a very powerful greenhouse gas. So think about what you put on your plate or what you buy, and try to waste less food. It's really, really important to waste less food. And if you can, try to grow your own food. And because the energy put forward to transport food from any place outside of New Hampshire into New Hampshire, and we do import most of our food. We really don't grow enough food to support us for more than 2 days in this state. We're getting asparagus from Peru, and people want that. So if you could just grow your own food, can it, and think about using local sources like supporting local farmers, you decrease a lot of the emissions associated with transporting food into New Hampshire. And if you do have waste food that you need to get rid of, the best thing to do is compost it. It avoids putting it in a landfill, and it also provides you with an opportunity to make great, great soil for next year's garden or flowers. So waste less food and grow your own if you can, but definitely compost. So now let's talk about energy use. And the obvious: shut things off, unplug things that aren't in use. Even when your computer is in sleep mode, it's using energy. Turning off computers and monitors saves energy, and it also reduces pollution. And if you have to buy new appliances or anything like that, look for this symbol, the Energy Star symbol. These products are already manufactured with efficiency in mind. 20% of energy is wasted in our country. The US spends $40 billion each year on wasted energy. And I think we can all agree there's much better uses for that money. And let's talk a little bit about phantom energy. I'm not sure if you're familiar with phantom energy. Phantom energy is energy that's being drawn, but it isn't being used. So for instance, if you leave your computer on and it's in sleep mode, it's still drawing energy. Or if you plug your cell phone in at night and you're off running in the morning and you just grab your phone and you leave your charger plugged in, it's drawing energy all day for no apparent use. So think about your phantom energy sources. And if you don't know, what you can do is get up tonight when everybody's sleeping at your house and walk around the house. And anything that's lit or shining, using energy. And so if you can eliminate those sources of just phantom use of energy by installing power strips or things like that, or you're going to save yourself money. Plus you're also going to stop that wasted energy that's being drawn from your house. Now here's a phantom energy fact. The consumption of phantom loads of electricity in the United States is equal to the electricity used by the countries of Greece, Peru, and Vietnam combined. So we waste as much energy as 3 countries use. So if something's not in use, unplug it or get a power strip. We don't need to waste this energy. So that's mitigation, or reducing our fossil fuel use. And what can we do to adapt? Because we do have to begin to adapt. So we have adaptation options, of course, and one is to do nothing and just sit back and see what happens. But I don't think any of us agree that that's a good idea. One of the choices we can do to protect against flooding, because flooding is one of the big things that impacts us in New Hampshire, is we can use armoring or protecting our critical infrastructures through things like seawalls, like we have here in Hampton, or levees that can protect roads from meanders and rivers once the rivers are swelling. And then even better, use natural systems to protect, such as dunes. So there's a number of ways that we can protect our critical infrastructure. Another thing we can do is create things to accommodate these flooding situations, like keeping good buffers intact around rivers and streams, and also keeping wetlands intact fully and protected because they act like sponges. So when we see big rain events, the buffers and the wetlands just suck up that water. They help to reduce erosion. They help to reduce the impact on water quality. And it's a great natural feature that we can all keep intact through conservation measures. You also see alternative construction techniques like this image on the right, where houses are being built on stilts. You often see this in coastal areas, and all the infrastructure for the house, the furnace, all the utilities are on the top floor so that they don't get impacted by flooding. So you accommodate, you plan to let this house flood by letting the waters flow underneath it. And then this is a very tough choice, but it's the choice of retreat. And retreat is thinking about relocating homes and infrastructure that are in highly vulnerable areas that are damaged repeatedly. And this is a hard issue in New Hampshire because a lot of our municipal dollars are derived from property taxes. So when you talk about taking properties out of harm's way, so moving these 5 houses and letting it be a natural landscape, you lose that tax revenue from those 5 homes. So it's a tough topic in New Hampshire, but we're seeing people be interested in this retreat or managed retreat in towns like Hampton right now in New Hampshire. It's also important to have personal adaptation plans. So you want to pay attention to storm warnings and act accordingly. Don't say, oh, this won't hurt me, or I can tough it out. Pay attention and have a personal and family preparedness plan that includes your pets, because if you're going to need to take off, you want to be sure everybody's taken care of, including the fuzzy people in your home. Be prepared to be without electricity. We keep empty jugs in the basement, and when we hear that there's a big storm coming, we fill them all up with water, because living in a rural area, if we don't have electricity, we can't flush, and that's a very huge limiting factor. We keep non-perishable food and batteries on hand. And another thing you can do is be aware of others in your community who might be dependent on electricity for health reasons, and help them, and be prepared to help them in times of no electricity. And look around your home and see if your home has adequate drainage in areas to prevent washouts. If you live on a street that has storm drains, please clean your storm drains. It prevents flooding, especially in times like this when there's leaves on top of all the storm drains. And maintain your driveways and culverts. So you want to move things out of the way that are going to potentially cause flooding. And remove large trees. Now, I'm not saying that I promote cutting down trees, but if you have a big white pine with branches hanging over your house and there's a lot of wind and rain events, you want to be sure that those branches aren't going to come down and hurt your house. Other things you can do to prepare yourself and adapt: do regular tick checks and be aware of the signs of tick-borne illnesses, both for yourself and for your pets. It's great if you can use rain barrels in your property, because it helps you to store water in times like this when we're in a drought. I have a couple of rain barrels outside that are chock full right now. You can also install rain gardens. They help to infiltrate large storm events and put that water back into the groundwater so that it's not running off into streams. You can purchase heat pumps or mini splits for heating and cooling. These are very efficient ductless systems that you can add to your existing heating system, and they're fairly inexpensive. We got one this year and we mostly use it for cooling. I can't believe I have cooling in my house in New Hampshire. And the way we use it is we just put it on dehumidify, and that keeps the home cool enough so that you don't feel that really hot feeling from the high humidity. We also have purchased drapes for our large slider on the south side, and those drapes keep the heat in the winter, but they also keep the sun out in the summer. And they're actually really effective at keeping the sun out in the summer and maintaining the coolness of the inside environment in your home. And then many people are purchasing generators so that they can have electricity during periods of no electricity. See if that's what you need. Another important thing is to participate in your community conversations to support preparedness and energy efficiency efforts in your town. This is really important, and it's on the minds of a lot of people in our state. And then you vote. You vote for local initiatives, including increased efficiency in your municipal buildings, culvert maintenance, tree removal, tree planting in more densely developed areas. So think about these impacts and how you can be a voice in your community to help lower the impacts and help people be prepared and more comfortable. So now let's talk a little bit about the projections for our future. So let me orient you to these graphs. You'll see a series of these. So the gray bars are the historical, what we had for extreme heat in this particular example between 1980 and 2009. The blue bars indicate what we might have if we do something to decrease our fossil fuel emissions, fossil fuel use and greenhouse gas emissions. The red bars are if we do nothing, if we just do business as usual. And we are pretty much in the red bar scenario right now. So that's what you really want to pay attention to. So now for this particular graph, we're talking about extreme heat, the average number of days over 90 degrees per year. And you can see that in this period of 2010 to 39, we're supposed to have about 10 days over 90 degrees per year. But if you remember to my earlier slides, I said that Concord had 25 days and Manchester had 32. And that's more of a scenario that you see here that was projected for 2040, almost a whole month over 90 degrees. And that's what we saw this summer. Now, again, it was the warmest, warm summer for us, but it's interesting to see how the projections for 2040 have already occurred here in 2020. So that's those high heat days. Now let's talk about a future growing season. If you're a gardener like I am, you think, oh, a future growing season is great. And our future growing season is projected to lengthen by about 2 weeks in the low scenario or about 5 weeks in the high emission scenario. But the hotter temperatures, reduced chilling at night, and more extreme precipitation will likely lead to decreased crop yields, not to mention pests, right? So although the growing season might be longer, it's a more erratic season. And so it's not necessarily directly attributable to a higher crop yield. In terms of future precipitation, in either scenario, we're going to see an increase in future precipitation of from 17 to 20% by the end of the century. And these increases in extreme precipitation, as you know, result in flooding, damage to infrastructure, decrease in water quality and erosion. And it's challenging to put up with these floods all the time. And we're going to have more, so we need to be prepared for them. And if you're an outdoor enthusiast, this is a sad slide, I'm sorry. But historically, we've had about 105 days covered with snow per year. By the end of the century, we could only have 52 days. Excuse me. So some of the ski areas in southern New Hampshire are going to be forced to close. But worse than that, excuse me, if you're a cross-country skier or an ice skater, you're going to have to go north to be able to take part in those activities because it's not going to be able to happen down here with these warmer winters and lack of snow-covered days. And this is a sea level rise graph that we just published in 2019, and it looks a little busy, so I'll explain it. But assuming the global greenhouse gas emissions begin to decline by mid-century, we are likely to see a 1/2 foot or 1.3 feet of sea level rise by 2050. And going out to the end of the century, it could be as much as 3 feet. And this is a very conservative projection. You can see the other projections indicate a higher probability of sea level rise depending on global greenhouse gas emissions. And so this rise in sea level could be much higher if global greenhouse gas emissions continue to increase or if we see ice sheet melting accelerating. And we are seeing some of that in Greenland as well as the West Antarctic ice sheet. And we need to pay attention to that. Sea levels will continue to rise for centuries. We know that. And because our coast is significantly impacted by nor'easters and hurricanes, these big storms drive ocean waters towards the land, and that's called storm surge. And you remember in Hurricane Sandy, the storm surge was like 14 feet and it inundated all the subway stations in New York. So we don't have subway stations in coastal New Hampshire, but we do see these periods of increased storm surge that cause flooding farther inland that lasts longer. And I mentioned early that as sea level rises, groundwater also rises. And we can expect to see 1 to 5 feet of groundwater rise as far as 3 miles inland from our tidal shores. So what happens, and you can see this in the image on the right, is as sea level comes up and the salt water begins to move inland, it pushes against this saltwater freshwater interface. And as it comes up, it moves that fresh water up into the system and can cause groundwater to rise. And the amount of groundwater rise isn't uniform or linear with distance from the coast. It depends on hydrogeology, if you have streams or wetlands, because it can make those bigger, your distance from the coast, and if you're doing groundwater pumping. We have communities in New Hampshire right now who are pumping groundwater for drinking water, and they're actually sucking salt water right into their systems. And so they have to come up with a different source of water because they've already created that pull of salt water into their drinking water system. So this is sort of a hidden thing that we didn't really know about. This research was published in 2017, and I was shocked when I read the research because I hadn't really thought about groundwater rise, but it's very significant, and it's going to impact our roads, underground storage tanks, drinking water wells, septic systems, and landfills. It's sneaking up, it's wetting the feet of all these pieces of infrastructure. So, and then there's exacerbating issues, right? We're going to see an increase in population because we have water, and there's a lot of displaced people who are moving from areas in California because of the fires, or from the Southeast because of the hurricanes, or from the Southwest because of the droughts. And we're also seeing people moving into our region because of COVID-19, because now they can work at home and they don't want to live in dense cities anymore. So they're looking to live in New Hampshire and Vermont and Maine, where we're less developed and we have open space, and they can move in and build more houses. And so there'll be more development. And as development increases, there's more pavement. And as there's more pavement, there's more runoff. And so we have more flooding, and homes are built in more risky areas. And so that puts people in harm's way. We have old infrastructure that's already undersized. And you saw in a couple of slides ago, we're going to have more extreme precipitation, so that we need to start to think about that. And at the same time, we're seeing federal funding decreases for these issues. And there's a lot of politics around this topic. And I'm sure you have other ideas of exacerbating issues that are problematic for our state and our region when we think about climate change and its impacts. So we're already seeing some people beginning to adapt. Power companies are trimming trees and limbs to try to decrease the amount of power outages. Communities are maintaining and upgrading culverts and replacing them when they're undersized. You see ongoing road and drainage maintenance. Many communities are making policy changes so that their communities can be more resilient. There's great work going on with targeted land protection efforts, trying to protect very critical lands that help with wildlife corridors, as well as streams and buffers and wetland protection. You see ski areas having alpine slides, canopy tours, and mountain biking, and many homes have backup generators. So those are just some ways that people are already beginning to adapt. So the message is clear. We need to do both mitigation. We need to reduce the amount of fossil fuels that we're burning and putting into the atmosphere. It saves money now and into the future, and it also reduces the amount that we'll have to adapt to. And then we have to continue to adapt. And proactive adaptation, including changes to our policies, our operations, and our capital investments, is a good idea, because if you invest $1 today proactively, you save $7 in recovery. So it makes sense to do proactive adaptation today. So I want to end with some positive notes, because we have met environmental challenges in the past. 40 years ago, we were concerned about smog. There was a nationwide effort to require catalytic converters on all vehicles, and it worked. Our smog has been reduced by 30 to 50%. Remember the hole in the ozone layer? We were very concerned about that. And there was a solution that was global to reduce chlorofluorocarbons, to phase out chlorofluorocarbons, because they were depleting the ozone layer. CFCs have pretty much been eliminated, and this ozone layer is slowly rebounding. And you remember acid rain, very big problem in the Northeast. And the solution to the acid rain was a market-based program for regulating utility sulfur dioxide emissions from the Midwest. The Midwest was in their utility operations, they were emitting sulfur dioxide that was being transported to the east, and as it met with water molecules, it caused sulfuric acid as well as nitric acid to come down in our rain and cause our lakes and forests to be severely damaged. And so this market-based program was a cap and trade program where there was a certain limit that utilities could only release, and they could work amongst themselves to decide who was going to release what, and they attached a dollar figure to the emissions that they could put out. And so it was a market-based system that worked, and our acid rain emissions have been cut by 50%, and our forests are rebounding, and our lakes are slowly recovering. And that market-based solution is the same thing that we have right now in the Regional Greenhouse Gas Initiative. And that initiative is an initiative of 10 states in the Northeast, and they have put a limit on greenhouse gas emissions through a market-based solution, and it's working. We're limiting the amount of greenhouse gas emissions going out into the atmosphere, and we're also doing it at a time where we're seeing economic growth. And that market-based system was what was in the Clean Power Plan that Obama introduced that it's no longer with us. The current administration got rid of the Clean Power Plan. If we can bring that back, it's a very potential successful opportunity for us to continue to reduce greenhouse gas emissions nationwide. So we have to make the connections, right? What you've learned tonight is that we're going to get warmer and we're going to get wetter. We're going to see shorter winters that are going to be warmer. We're going to have hot and humid summers. We're going to see more vector-borne disease, tick-borne, mosquito-borne illness. We're going to see flooding, and we're going to see drought. And so we have to make the connections that all these extreme weather events we're seeing around us are indications of climate change. And the Government Accountability Office stated that climate change is going to cost us more than $500 billion this decade and trillions more into the future unless we can mitigate the impacts. We can't ignore the impact of climate change on our public health, on our environment, and our economy. And the lessons will continue to be taught until they are learned. So we've got to connect the dots. You all here have just learned a tremendous amount. This is being recorded. It will be on the website of the Charitable Foundation, and you can look at it again and again. You can contact me if you have any questions, but we've got to connect the dots. We've got to connect the dots ourselves as well as with our neighbors and our community members. And we have to work together. We have to raise our voices as state agencies, regional work groups, all of our communities and conservation groups. We need to work together because a shared voice is a strong voice. And this is a critical issue. This is a very critical issue for our planet. We have to work together, and we have to work together at the local as well as the national and the global level. So thank you very much for spending this time with me. And if you have any questions, our moderator is accepting them through the chat, and we'll be able to share the questions, and I'll do my best to answer them. Thank you so much.
Thank you very much, Sherry. This is Chris, your moderator again. I do have some questions that I've been collecting and sort of grouping since things started. We do have an administrative question just relating to the slides themselves instead of within the presentation. Would you make those available too, or we'll post the presentation, the recorded presentation with the slides in it?
I have sent you a PDF of the presentation, so if you would like to post that on your website along with the recording, that would be absolutely fine with me.
All right, I have some technical questions for you. So Richard asked, there's increased precipitation and drought. Shouldn't the precipitation take care of the drought?
You would think so, right? Except it's a timing issue. So we're seeing increases in precipitation in fall, in winter, and in spring, and then we see these periods of drought in summer. So it's not rhythmic. It's not synced well. So yes, you would think that that's a logical thought, but it's not, because it doesn't always occur that way where the precipitation will take care of the drought.
All right. So Jane asks, besides a warmer ocean temp and weaker Gulf Stream, What are the other potential effects of climate change? I think we
In the
discussed
oceans?
some of them. It was more broadly, I think it was earlier on in the presentation before you'd gone through some other things.
Sure. I think I probably have answered that, but one other thing in the oceans that I did mention tangentially is ocean acidification. And when carbon dioxide goes into water, it bonds with a water molecule to form carbonic acid. And that acid will degrade coral reefs. It will degrade shells on shellfish and clams that I mentioned. And so there is a problem of ocean acidification as well. So it's that I think is where she was going a little bit with that question.
So Brad asks, is there any relation between geomagnetic pole migration and climate change?
That I do not know the answer to that, and I don't want to pretend that I do. So I'm going to have to pass on that answer.
Oh, okay. And then we just got a new question that kind of relates to an old question, so I'm going to kind of combine them together. So Joan had commented that she'd read that methane is more damaging greenhouse gas than carbon dioxide. And then, sorry, just getting questions pouring in here. And then Sue asked, could you address methane as a greenhouse gas and its relationship to natural gas and fracking?
Sure, yes, methane is a byproduct of natural gas and fracking. And the reason we talk more about carbon dioxide in the atmosphere than we do methane is a really powerful greenhouse gas, but it's more short-lived. Methane will live in the atmosphere for probably around 20 years, whereas carbon dioxide, as I said earlier, can be hundreds to thousands of years. So methane is a very potent greenhouse gas. And yes, we do talk about it, but for presentations like this, we often talk about, your carbon footprint, and people want to know more about CO2. But yes, methane is something that comes out of landfills. It comes out of fracking, and it is a part of natural gas. So yep, methane is definitely something to also be concerned about.
So Andrew asks, what is the possibility of cold Arctic air being exhausted completely? If it did happen, what would Canada and the United States look like?
We would be much warmer. We would, the Arctic is the air conditioner to the Northern Hemisphere, right? It keeps us the way we are. So if we were to remove that, we would be much, much warmer, and it wouldn't look like Canada or Northern United States anymore. It would be much warmer. And I don't know if any scenarios have been run about full emptying of the Arctic, but we do know that with the decrease in the Arctic and Antarctic ice sheets, there could be significant warming as well as significant sea level rise. So I think we'd be warmer, I think we'd be wetter, and I think we'd be much wetter because the sea level rise would be much higher than it is today, or is predicted to be.
So all right, so I think that's all of the technical questions we have so far. So the next kind of fall into the category of what can we do and what are we doing, or what are we putting our fingers in our ears and not doing. I think it's Joseph asked, what steps can towns take to increase the use of renewable energy, both for the town and its citizens?
Great question. I think it's got to start with education, because often people think about the bottom line, and we're in a tough economic time right now. And so making the connections between what we've just talked about here and the changes you're seeing in your community, and if you're working with your community to cite alternative energy or to do efficiency initiatives, use examples that have happened in your town. Like I live in Orford, we had that huge flood. This flooding is coming from a changing climate. If we could do more efficient municipal buildings and maybe purchase a solar array, we would ultimately save ourselves money from recovery. So I think you have to start with education, because not everybody understands all of this information as well as you might. And so starting with education, as well as bringing in some community voices to help them understand, find the community champions, the people in your town who are very active and who are well respected, and bring them in and have them support these initiatives. because once you move together as a community, the power is mighty, and you can help people understand that they are being part of the solution to this issue, because it's in the news all the time now. People know, and you see it in your own town, you see it in your own home. So work together with your community, get education into people's hands so they know that this information is out there, and help them to understand, help them to make the connections.
All right. Dan asks, what is your opinion on geothermal heating, cooling for residential use? Pros, cons?
I think it's great. I think it's a great alternative to choose. It tends to be expensive in the installation phase, but ultimately, you have to think about, the cost benefit, right? So if you put in money up front, it will last for a long time and it's very efficient, and then you reduce your costs over time. But it's not always something people can do, and many of us already live in our houses. Sometimes it's harder to add a system like that. It's easier in newer systems or newer homes, but I think it's a great alternative and something that many people are taking advantage of.
Got kind of back to a sort of a technical question. So Leanne asks that methane is also associated with mass animal ag, and
Oh, yeah.
leaning towards eating more plants might make a difference. Why is it not often mentioned in climate related presentations about sort of plant agriculture issues?
Sure. Yep, that's a great question, and that's absolutely right. Methane is associated with large-scale industrial farming emissions. And yes, if we could eat a more plant-based diet, that is a great way to limit the amount of energy that's put into growing meat and putting out methane into the atmosphere. It's hard to talk about dietary choices with the general public because I've been a vegetarian since 1980, and my parents used to say, "What, you don't eat?" And it's like, no, I eat all the time. Look at me. I just don't eat meat. And so when you get to those ethical questions, sometimes people get hair up on the back of their neck. And so we try to avoid having people feel defensive during these types of conversations. But yes, if you don't want to eat a fully plant-based diet, why don't you go for a meatless Monday or something like that? So where you're looking at your meat sources and where the meat comes from, right? So if you're going to choose to eat meat and you live next door to a farm like I do, you could buy meat from your neighbor if that's what you want to do. So if you want to eat meat and you want to buy it locally, that's less intensive on the planet than it would be from factory farmed meat. But again, it's hard to talk about people's dietary choices without getting some folks feeling uncomfortable. And we don't want to do that. We want to stay unified on this issue because there's many ways to approach the issue of reducing the impacts on the planet.
Thank you. Jess asks, is it possible to do a cap and trade carbon limiting? And how much would fuel costs go up due to related taxation?
Right, it is possible. And that was what was put forward in the Clean Power Plan. And I don't have details about how much costs would go up because I haven't fully done that type of analysis myself. But what I do know is that it is possible to have a cap and trade program that is successful and that does allow for continued economic growth, because we've seen it with the Regional Greenhouse Gas Initiative here in the Northeast.
Thanks, Sherry. So the next grouping of questions kind of comes under the interface of these issues and government. And so Sue asks, given the financial, ecological, and societal impacts of climate disruption, is it time for localities, states in the US to declare a climate emergency?
I think many have.
Yeah.
I read about the climate emergency all the time. And I think it is something that, if you don't want to declare an emergency because of the optics around that's up to your community and that's up to you. But I think we all can agree, just watching the news or reading the news, however you get your information, there's something about climate impacts almost every day now. And so I think it's time to really double down and really start to look at how we personally use our fossil fuels as well as how our communities use fossil fuels, and get the message out there that we want to see change for us here now, but also for the future. And little babies born today are going to be 50 years old in 2070. And you saw some of those projections of what it's going to look like in 2070. And so we need to think about future generations and what do we want to leave behind as our legacy.
So Joy writes, New Hampshire is doing less than other New England states. The New Hampshire legislature has passed several bipartisan bills which have been vetoed. She knows a voting is important, but what else can we do?
Talk to your legislators. Talk. The one thing about the large legislative body in New Hampshire is they're very accessible. We all know our legislators in our communities, in our regions. Talk to them. Let them know why you care. And yes, we're the donut hole in New England. Let me tell you how embarrassing it is to be in, I'm in a lot of New England-wide meetings with other states and everybody's talking about what they're doing. And I feel so sad that we don't have the support from our administration at this point in time. And so we need to continue to let them know that we want to see change. We want it in New Hampshire, just like Vermont, just like Maine, and just like our Southern New England counterparts.
Great. Sally asks, we currently have a Republican governor. Does he accept the reality of human-caused climate change?
I'm not sure.
We had a few late arrivals. If you're still up for a few more, Sherry.
Absolutely.
Okay. Joan writes, I know that idling accounts for a small percentage of fossil fuel emissions, but New Hampshire has an anti-idling law. Not sure, but she thinks its engines must be turned off after 2 minutes. That is not well publicized, and as far as she can tell, not enforced. Do you have any opinion as to whether towns and cities should try to persuade their municipalities to enforce the law?
I think that enforcement's hard because it's confrontational, right? If you're sitting there idling your car and texting, which is my biggest pet peeve, I see it all the time. And I feel like knocking on windows saying, excuse me, could you turn your car off? People idle and text all the time and it makes me crazy. But if you go to talk to them, they could get defensive. And so a different approach would be to obtain signs that say no idling. And we have those signs in our office and they're available to municipalities for free. And you can post them in areas where there's common pickup points, like at schools or at businesses or places where people run in and just leave their cars on. So it would be great if we could enforce that, but it's a really hard thing to enforce and nobody wants to be the turn off your car police. So by doing it through education and leading by example, we could help each other understand what idling can do. And ultimately you get 0 miles per gallon when you're idling. And so there's a cost savings that's associated with idling as well, with not idling.
Carol writes, we live in a pickup truck, low fuel efficiency state. What incentives are there to shift this consumer obsession?
Sorry, I just have to laugh. Yep, we do live in that kind of a place. Making the auto industry adhere to strict fuel emission standards would be a great place to start, because then people could still have their trucks and they could be very happy in their big trucks driving all by themselves, but their emissions would be less because there would be a manufactured efficiency built into their vehicle. And I think that's a great thing that we could do. We did that, but then that got overturned.
I was gonna say, Joan just tacked on to that. Have we backslid on that issue in the past 4 years?
Yes, we have.
Different Joan writes, I've read that employing sustainable farming techniques could significantly reduce climate change. Is New Hampshire working to educate its farmers and meat producers and providing incentives for them to make modifications?
We are educating, at least master gardeners, and I'm not involved with educating meat producers or any people in the large agricultural sector. but I do education for Master Gardener programs and other programs throughout the state, helping people understand what sustainable farming and growing can look like and how it benefits the environment. There are no incentives in this state for encouraging agricultural operations to be more sustainable, unfortunately. So yes, I think incentives would be great, right? Because then obviously people would have a little financial reason to think about it. And often sustainable practices are exactly what they're called. They're sustainable. And so they're longer lasting. You can often get better yields, have, yes, less pests and things like that, but it's just not the norm yet. And we need to continue to try to move it into the norm.
As a master gardener, I would tack on to that both the master gardeners as well as the NOFA NH, the Organic Farming Association of New Hampshire, are doing a big push in this area, and including, if you've heard of the new documentary that came out, Kiss the Ground, which relates to sustainable agriculture, and sort of using that as a platform for continuing education in this area.
That's awesome. Thank you for what you're doing. Much appreciated.
And I think that's it for the questions.
I have a closing point that I'd just like to bring up for those of you who like David Attenborough. I'm not sure if you have seen his most recent program. It's called A Life on Our Planet, and it's his swan song, and it's in perfect David Attenborough fashion. I watched it on Netflix the other night, and if you haven't watched it yet, you should, because he talks about the wonderful nature of the planet, and then he brings into close focus the impacts of climate change on our planet. And it's a great, great show. So I just wanted to mention that to you all.
All right. Sean, do you have some closing remarks?
Can you hear me?
Yes.
Yep.
Okay. Sherry, I want to thank you so much for a brilliant presentation, so informative on so many different levels. Thank you for sharing your information with us so that we can get it to the website so people can see it again, not only the recording, but looking at your slides. I also want everybody to know that Cable Access TV in Vermont and New Hampshire is also picking up this presentation. And so watch their menu or their directory for times and days. Once we get it over to them, they'll be airing it too, because what you are doing and others like you are doing is so incredibly important, not only to our state, but our region and ultimately our country. So by starting small and growing it big, we can really make a change. And Christina, I want to thank you for your awesome moderating skills. It's been wonderful, and I hope everybody here has enjoyed the evening. And we hope to bring you another exciting and informative environmental education program in the next couple of months. So thank you all and have a great evening.
And thank you, Christina, for making my job so easy. Thank you, Sean. Have a great evening.
Thank you, Sherry. Thank you.
Everybody. Everybody have a good night.
Thanks, you too.